Greetings, if you're watching this video it is because you are hopefully doing advanced game design at QT and not for any other strange reason. This video is designed to get you up to speed with the Unit and Unity 3D as quickly as possible. You'll be using Unity in this introductory video, so make sure you have the latest version of it installed on your system. You can download the free version from the following link or simply by searching for it in your browser. So what exactly is Unity 3D? On Wikipedia, Unity is described as a cross-platform game creation system which includes a game engine and IDE used primarily to develop games for PC, console and mobile devices. And that is actually a pretty good summary of the software that we will be using in this unit. But it is important to note early what Unity is not. Unity is not a 3D modeling or animation program like Maya, 3ds Max or Blender. It does not have the tools to create elaborate textures or 2D pixel art, nor the appropriate tools to author music or audio files. While you can design levels in Unity, it is not its primary function, nor does it excel at it like CAD programs would. In fact, Unity has very little to do with generating game assets at all. However, it is an excellent tool for bringing these assets together and making a video game with them. In the context of this unit, we could describe Unity as a suitable tool for making game objects interact with each other. When we think about the vast majority of games that we play, this is predominantly what is occurring. While there are rules specifying exactly how these objects interact, at its core, most games involve game objects spawning, moving about, interacting, and eventually despawning in various ways. In this unit, we will be using Unity primarily for this intended purpose, providing you with minor content for expansion into your own game ideas and mechanics. We will talk about the tutorial content shortly, but for the moment let's just get stuck into Unity. So, we're going to make a very simple game. This game will demonstrate to you the fundamental process of objects interacting in 3D space. This is important as most of the games you create in Unity will essentially be extensions of this basic derivation. To do this, create a new project in Unity without importing any of the packages. Those packages provide additional assets and features that we won't need for this game, and they can be accessed later by going to Assets, Import Package. Instead, we are going to make a cube. Every game starts off as a cube, and this one is no different. Do this by going to Game Object, 3D Object, Cube. If you set your layout in Window Layout to 2x3, your Unity should look the same as the one in this video. We can find our cube in the game hierarchy alongside the main camera, which is placed there by default to provide a view to the game. The hierarchy can be described as Unity's visual representation of the game's scene graph. Objects can be parented to each other and nested in groups for access or housekeeping reasons. Selecting our cube, we can also duplicate it by right-clicking on it. Do this twice so that you can end up with 3 cubes in the hierarchy. Right-clicking on the cubes, rename them to Player, Enemy, and Projectile. Now, one of the components of all game objects is what's called the object's transform. The components of an object can be seen in the inspector view on the far right. Components of an object are listed in relative order of importance. Components can be added to objects or removed. An example of a standard additional component could be a script. If you select the player cube, you will see its transform position is currently on the origin, or 0, 0, 0 on the X, Y, and Z axis. If it is not for some reason, move it and all the other cubes to the origin now, so that they are all at the origin. From there, change the player cube's y-axis to -3. You will see the cube has dropped down in both the scene and game view. You can manipulate this cube using other Unity controls such as the move, rotate, and scaling controls, but for the moment we just need it at -3 on the Y. Additionally, if your camera is not at 0, 1, negative 10, adjust its transform properties so it is positioned correctly. Now, we're going to make this player move, and to do that we need to make a script. While this unit is not about learning how to program, a decent level of scripting comprehension will be necessary for you to succeed. If you are not familiar with scripting, I would suggest following this section carefully, as well as investigating basic scripting in C# in your spare time. A script on a game object is a component, but before that it is an asset. If you go to the project window and right-click on Asset, you will get the option to make a C# script. Let's call this script Player to keep it simple. Open this script in MonoDevelop by double-clicking on it in Unity. MonoDevelop is the standard scripting platform for Unity and is recommended that you use it for scripting. To start, we want to move this object around and shoot a projectile, so let's set up some variables to allow that to occur. Both of these variables are public, which means we can access and override them in Unity from the inspector view. We will do this shortly, but before then, let's get some movement sorted. Now, update is important as it ties directly to what is called the game loop. Every loop or frame that the game runs, anything that is in update in any script that is on a game object will be run. From update, you can call other methods to perform more complex operations, but to make this straightforward, let's do everything within update. All we are going to do is move left and move right along the x-axis. To do this, we are going to need to write the following code. So one question you may be asking is what on earth delta time is. To put it as simply as possible, delta time is the time between frames or loops of the game engine. Delta time is therefore a useful coefficient for normalizing stuff like movement speed to the performance of your computer. You can save your script quickly using Ctrl and S. As you would imagine, this script will move our player cube left and right at the designated move speed every game loop during which we press either the left or right keys. In this case, these keys have been set up to be A and D. Going back to Unity, attach this script to your player cube by selecting the player and dropping the script alongside its components. Now press the play button at the top and play the game. Alright, you have made a game mechanic. An incredibly simple one, but one nonetheless. We should fire a projectile now, but first we need to set it up. Select the projectile cube and resize it so that it is about half the size of the others. You can do this precisely using the object's transform component. Now, make a new script and call it projectile and open it in MonoDevelop. For this projectile script, we want 3 variables: its speed, its damage, and how long it lasts. Set these variables up with the following lines of code. Again, these variables are public, which means we can override them later within Unity. To make this projectile move along the y-axis, add the following code to the projectile script's update function. We also don't want too many of these projectiles floating around, so we're going to set up a simple timer that automatically kills the object if it lasts for too long. Do this with the following code in start, followed by the following code in update. Back in Unity, drag the projectile script onto your projectile's components. If you press play now, your projectile will take off. However, before we make our player fire it, we must turn our projectile into a format that is readily accessible for spawning by the game engine. You will typically do this to game objects that will be repeatedly spawned or instanced in a game environment, such as a pickup, projectile, or even an enemy. In Unity, it is called making a prefab, and it is very simple. Select your projectile in the hierarchy and drag it directly into your assets. Done. Now, delete the projectile from your hierarchy so it is no longer visible within the game. If you select your player, you can drag the newly created projectile prefab into the projectile variable of your player script component. Finally, go back to your player script and add the following lines of code to update. If you go back to Unity and play the game, you will now be able to fire projectiles from your player using space. Great! So now we have a player that moves and can shoot stuff, but it's not really much of a challenge at this point. To fix that, let's make our enemy actually do something. First, let's make this enemy move with a simple animation. Select the enemy in the hierarchy and go to Window, Animation. Click the Add Curve button and create a new animation called Enemy. Select Transform, Position from the drop-down list. Move the keyframes on the right to the 2-second mark, then snap back to the first keyframes by pressing the back button in the top left. Expand the position list and delete the Y and Z keyframes from both the left and right hand sides. You will notice the enemy will transform back to the origin in the background. Don't worry about that, we will address that in a second. At 0 seconds, make the enemy be -3. Go to 1 second and add a keyframe by right-clicking. Make this keyframe at 3. Finally, at 2 seconds, make that keyframe -3 as well. If you play the animation, you can preview its behavior. So, close the animation window. If you select your new enemy animation asset, you can change its wrap mode to loop. Now select your enemy and add an animation component by Component, Miscellaneous, Animation. Extend the animations list in this component and set the size to 1. Add the animation to the first element and make it the default animation as well. If you play the game now, you will notice that your enemy has become mobile. However, it is again out of position. Even if you were to move the enemy back to 3 on the Y, it would still snap back when you play the game. This is because animations are played relative to their origin. To fix this, we can make a blank game object called an empty and parent our enemy onto this empty. Do this by going to Game Object, Create Empty. Transform this empty to the origin at 0, 0, 0. Now, in the hierarchy, drag the enemy onto this empty, making it a child object. The enemy will now animate with reference to its new point of origin, in this case, the empty. Rename your empty and enemy to something sensible and move the empty to 3 on the Y-axis. If you play the game now, the enemy should now animate in the desired position. At the moment, our enemy is unkillable. This is mainly because while our projectile moves, it doesn't physically collide with anything, and if it did, it wouldn't do anything anyway. To fix this, let's first make our projectile actually have the capacity to register collisions with objects. We can do this by adding a rigid body to our projectile prefab by first selecting it in the asset view and going to Component, Physics, Rigid Body. Untick the Use Gravity option under this component as we don't want it to fall down in this game. If you were to play the game now, you may notice your projectile firing off at random angles, which is bad. This is because we are spawning our cube from the center of our player, which has a box collider. You would normally not do this, as you would spawn projectiles externally to players or weapons. This can be achieved via using additional parented empties, but convenience sake, let's just turn off the player's box collider. After doing this, your projectile's behavior should return mostly to normal. except when interacting with the enemy. Currently, it does nothing, but what we want it to do is cause damage to the enemy and disappear. Now, there are many ways to go about doing this. The most sensible way is to make any object that this projectile collides with take damage if it is capable of taking damage from it. To make this work properly, we need to return to our projectile script. Go back to MonoDevelop and add the following code to the bottom of your script. Within this bit of code, we are performing a send message process to any object tagged as enemy. It communicates to that enemy object, telling its take damage function to deal with the specified amount of projectile damage. We could add additional tags to this process, or even pull out the tag check completely if we wanted all objects with the take damage function to take damage from this projectile. For the moment though, it doesn't hurt to be specific. Save the script and go back to Unity. We need to tag our enemy with an enemy tag if we want our script to work properly. Select the enemy object in the hierarchy and not the empty it is attached to. Now, go to tag just under the object's name in the inspector view. Go to add tag and under element 0 type enemy with a capital E. Select our enemy object again and repeat this process, but this time select the enemy tag that you just added. Finally, we need to make one more script. And this one is really straightforward. Make a new C# script and call it enemy, and add the following line of code to the top of the script. Now add the following code to the update function. Finally, add the take damage method that we discussed previously. So hopefully you see what we are doing here. This is the function that will eventually pick up the take damage message that we set up on the projectile. Save this script and go back to Unity, and then attach this script to your enemy object. If you play the game now, you should be able to shoot down the enemy with approximately 5 shots. Congratulations, you have just finished the introductory game. It seems primitive, but it encapsulates the fundamentals of game object interactivity. You have a player that you move every game loop that can spawn projectiles that move forward to hit and eventually destroy an animated enemy. Changing the movement speeds, fire rate, damage, and health of variables would be your first step towards tweaking this game's mechanics. For those who have never done programming before, this may seem like a lot to just get something so basic working. And this is true, there is a lot of work, particularly scripting, in modern games. If you have had trouble writing the scripts up in this video, they should be available on Blackboard for your reference alongside the project. Again, I would highly suggest that if you are unfamiliar with scripting, particularly in C#, that you look into the basics, just so you have an idea of what is happening in the weeks to come. The tutors will help you as much as possible, but there is only so much that we can do. Speaking of which, we should wrap this up by talking about the tutorial content structure. Besides this video, you will have 3 additional tutorial packages to be completed in sequence. Each one contains a primitive game in a prototype stage. They are incredibly basic, but focus on a particular game genre. You are expected to expand upon or redesign these game packages, designing, creating, and delivering new content that will then be marked based on a standardized criteria of expectation by your tutors. This format allows you the freedom to pursue and master the aspects of Unity and game development you are personally interested in. Minor instruction will be given where necessary. However, you are expected to research and investigate your own solutions to your design problems, of which there is a heap of tutorial content for. We will provide links to some of these tutorials where necessary. And finally, the packages consist of basic scripts and mechanics, as well as assets, which should be used for your assignments. That's it. If you have any questions, please ask on the potential Facebook group page or send an email to one of your tutors. I hope you have fun with this unit and good luck with your assignments.